We talked to you what will happen if we have low pH, I mean in the low amount of carbonate ions and high amount of bicarbonate and CO2, we have very fragile and deformed carbonate calcium structure in skeleton of corals. But now I want to show one good example to know what will happen if we have high pH and calcium carbonate supersaturating rate. Holcomb and et al. In 2009, they answered to this question. They showed that the coral crystal structure starts to deform and grow differently in the high pH and calcium carbonate supersaturation rate. Let's explain with this picture. They provided 5 environments with 5 different pH. As you can see in this picture, pH with 9.6, 9.2, 8.7 and 8.2. That 8.2 is its normal pH of our ocean. In fact, they changed the calcium carbonate saturation rate with pumping different amount of sodium carbonate to provide different environment. Unfortunately, they did not mention the amount of calcium carbonate saturation rate and carbonate exactly. They just mentioned the pH and sodium carbonate that was pumped in the different quantity. They showed that in the supersaturation rate with pH 9.6, we have granular to finely coral fibers in crystalline structure, and with pH 9.2 in supersaturation state also, we have a blood-like crystal fibers. If we have just a little increase in the pH until 8.7, the coral fibers arising from a center of calcification widely spaced blood. And the pH 8.2, that it is the normal condition of seawater chemistry, we can find the common form of coral fibers which arising from a center of calcification widely spaced in the blades form. The structural response of scleractinian coral to the alkalinity change have not yet been understood well, and most studies are needed to clarify the calcification process and the structural response of scleractinian coral to global warming and ocean acidification. Structural response in the scleractinian coral to the temperature change. With increasing temperature up to 25 until 28 centigrade, the calcification rate starts to increase. But at the above of 28 centigrade, the calcification rate starts to reduce. At only just 1 until 2 centigrade above the optimum temperature, the calcification process can be stopped. A possible explanation for the impact of temperature on calcification is that temperature affects the activity of calcium ATPase in the coral epithelium cell. A significant correlation has been seen between temperature and enzyme catalyzed reaction in the coral Galaxia fascicularis. A study by Hu and Marshall in 2002 showed that the crystal formation in the skeleton of Placistera versipera depends on temperature strongly. They also discovered that in the presence of light, calcium carbonate deposit is as a small spheroidal crystal, while in the darkness it deposits as an amorphous sheet-like cementation. At temperature 21 centigrade, it mostly looks like a small needle-shaped crystal with some spheroidal crystals, and in temperature 15 centigrade, it looks like as a spheroidal crystals. This picture shows to us scanning electron micrography of mineralization on skeleton spin in Placistera versipera at different temperature. As you can see, under light and dark condition, we have different form of crystal structure. SP is mean small spheroidal crystals. CA is mean area of smooth cementation, and NMS it's mean non-mineralized spaces, and N it's mean needle-shaped crystals. A and B are the skeleton deposition at 10 centigrade, at 1200 until 2400 hours respectively. And C and D represent skeleton deposition at 15.5 centigrade, at 1200 until 2400 hours. And E and F show to us skeleton deposition at 21 centigrade at 1200 until 2400 hours. In the study by Reynald et al. In 2007 on the effect of temperature on magnesium to calcium ratio in the scleractinian collar of Acropora sp, it showed that the increase of temperature from 21 until 29 centigrade increased the rate of calcification 5.7 times, and its increase also magnesium to calcium ratio in the scleractinian collar until 30%. Although other study by this author in 2003 on scleractinian coral Stylophora pistillata showed that the increase of temperature until 28 centigrade with high amount of PCO2 can reduce the calcification until 50%.